Thank you to Willow Class for sending me all of your questions. And this last video is the grab bag of questions. So we've got a whole variety of different subjects that you asked me about. So we'll get started. So the first is, what is the moon made out of? So the moon is made of the same materials as Earth. In the early days of the solar system, there were lots of protoplanets around on crossing orbits, so they would collide with each other. Some impacts would destroy, some would merge. And from those collisions, from that process that we call accretion, the protoplanets gradually combined into the 4 terrestrial planets we have today: Mercury, Venus, Earth, and Mars. Towards the end of that process, a Mars-sized protoplanet that we call Theia collided with the proto-Earth and smashed off a large portion of the Earth's crust and mantle. This molten, rocky material then went through another phase of accretion. So those collisions, bringing together the lumps of smashed up Earth and Theia, and they all collided in orbit to form the moon. The next question, how hot is the sun? So the sun is about 6,000 centigrade in the on the photosphere, the bit that we can see. Don't look at the sun without protective solar viewing goggles. So the bit that we can see, the photosphere, is 6,000 degrees centigrade, which is similar to what we think that the center of the Earth is temperature-wise. Further out, the corona reaches 1,000,000 degrees. And we also think that inside the sun, the temperatures reach 1,000,000 degrees centigrade. So the next question is, why is the sun so hot? And the answer is all to do with nuclear fusion that's occurring at the core of the sun. And I have a strange analogy here as to why nuclear fusion is occurring at the center of the star. And that is to imagine that a friend sits on you and you would feel a little bit squished. Now imagine if Mr. Clementson sat on you, you would feel a lot squished. And that's because Mr. Clementson has more mass. He's heavier, more massive than one of your friends. And so if he sits on you, the downward force that his mass creates is more than a smaller friend. The sun is so massive that the downward force of all of its weight is creating a really high pressure environment in the core. And it's so much pressure that it can actually force the elemental particles together so that the element of hydrogen can fuse to become a helium atom ultimately. And this process releases massive amounts of energy. And so that's what makes the sun hot. I'm going to combine the next two questions, and they are, what is the biggest and smallest planet in space? And also, is Mars big or small compared to other planets? I'm going to use these questions as an excuse to show you a really cool video that compares the different sizes of planets in our solar system. A caveat to this is that the question asked, what is the biggest and smallest planet in space? Now, we don't know for sure. We probably haven't discovered them. There are planets much larger than Jupiter, and there are planets much smaller than Mercury. But this video is just for our own solar system. So first up is a dwarf planet called Ceres that exists in the asteroid belt between Mars and Jupiter. Then we have another dwarf planet, Makemake and Haumea. Both of these are off in the Kuiper belt that is beyond the orbit of Pluto. We have Eris, which is also a dwarf planet. And here we go, the most famous dwarf planet, I believe, is Pluto. So Pluto is smaller than Neptune's moon Triton, which you see here, and also a lot of other moons. So Europa, that is a moon of Jupiter. Here's our own moon, Luna, and then a volcanic moon of Jupiter called Io, and then an icy impact-cratered surface of Callisto, which is smaller than the planet Mercury. But Mercury is smaller than Jupiter's moon Titan, Saturn's moon Titan, and Jupiter's moon Ganymede. Then we have Mars, so here's the answer to that question, which is the second smallest terrestrial planet, and then we have quite a large jump in size to Venus and Earth. And now, when we finish with the terrestrial planets, there's an extremely large jump in size when we have the ice giant Neptune. It's important to note at this point that this is not the solar system in order. This is just in order of size. Uranus is a similar size to Neptune, just a different color, slightly different makeup. And then we reach the gas giant planets, so Saturn and Jupiter. Saturn would be the largest if we included its rings, but if we just look at the diameter of the planet itself, Jupiter is by far the largest. If we zoom out again, you can get an idea of the relative size of these planets. So the next question is, how many stars are there? So we don't know an exact number. All of these numbers need to be estimated from counts in a smaller area. So we've estimated that there's 100 billion stars or more in our galaxy that we call the Milky Way. And that's just our galaxy, 100 billion stars just in our galaxy. And the estimate, a very rough estimate of 100 billion galaxies in the observable universe, there will be, and I had to write this down, 10 billion trillion stars that we estimate are in the universe around us. And this brings us on to one of the last questions I have, and that is, do aliens exist? Probably. I don't personally know of any aliens. There's no special NASA information that I'm aware of. We haven't found any evidence of alien life on the different planets that I've been working with. But just thinking of that many stars, that's a lot of places that planets can form around. And the more that we're looking out into space, the more we're finding that stars tend to have planets, or at least the stars that are the same age as our sun tend to have planets. And so if just 1% of all of the stars we know about had a planet around it, and just 1% of those had life form on them, that's still very, very many Earths. So the answer to are there aliens is probably.